Good afternoon, everyone. My name is Sherry Lynn, and I'm the product manager for AWS Dedicated Local Zones. And I'm excited to have the opportunity today to talk to you about data residency, the AWS Well-Architected Framework, and hybrid cloud solutions. Did you know that there are about 60,000 people here at re:Invent today? It's a lot, right? And I know, Kevin, you've traveled from Singapore to be with us here today, and you're representing Singapore GovTech, which is an agency of the Singapore government. And I'm curious, for those of you in the audience, what industries you all represent. Are there other folks that are from government or public sector here today? Okay, I see you. How about financial services or banking? Okay, quite a few of you. Great, welcome. Telecommunication services, anyone? All right, how about healthcare services? Okay, definitely some folks in the crowd. And for those of you who did not raise your hands, I know there are other industries I just didn't get a chance to roll call out here today. It's always amazing for me to see how much the topic of data residency matters to customers from all over the world. And it's also interesting for me to see how much your data residency requirements differ between customers, between industries, between countries, states, or even jurisdictions. So what I'd like to do today is offer you all with a few tools to help you architect for the cloud with your specific data residency requirements in mind. We'll start with an introduction to the AWS Well-Architected Framework, which offers best practices to help customers build secure cloud applications. And then I'll talk about the AWS infrastructure solutions and services, including AWS Regions, AWS Local Zones, AWS Dedicated Local Zones, and AWS Outposts, which extend the AWS cloud to more geographic locations around the world to help customers achieve their data residency objectives. We have a special guest speaker with us here today, and that is Kevin Ng from Singapore GovTech, and he's going to be up here to talk about this journey that the Singapore government went through to architect their applications for data residency in the cloud. And then at the very end of our session, we're going to have a demo by Lakshmi, who's going to be showing you how services and AWS infrastructure solutions can work together to create data residency guardrails and enforce compliance.
Thank you.
So let's start with, what is data residency? Broadly speaking, data residency is the requirement to store or process data in a particular geographic location. It's a topic that we tend to see come up with customers who are in regulated industries, like financial services or healthcare services, or in public sector or government, or in multinational organizations with locations all over the world. And this topic tends to come up for these customers as they consider moving their workloads that have been traditionally in on-premise data centers to the cloud. And as they consider their multitude of options for infrastructure solutions that can store their data in various locations around the world in AWS Regions or hybrid cloud solutions, this tends to trigger some fundamental questions about where applications that used to run in their own data centers can now reside in the cloud. And these considerations can stem from a wide variety of different use cases. Now, some customers need data residency in order to comply with regulatory requirements. For example, FanDuel, which is a gaming customer, needed to move their online betting systems to the cloud while ensuring that those applications would remain within certain state boundaries. Because US law stipulates that betting and games of chance can only be done within certain states. Other times, customers need to achieve data residency in order to achieve a latency target. For example, NASDAQ needed to migrate US options and equities markets to the cloud while ensuring microseconds of latency to on-premise systems for their order-to-trade processes. And NASDAQ worked with AWS to use Outposts to achieve those latency targets. Other times, customers have requirements for data residency because they have multi-year migrations involving many interdependent applications and large data sets. For example, a large healthcare services provider worked with AWS on this problem. They needed to move their SaaS applications to the cloud while their end user customer health records would remain in on-premise databases. And so this customer worked with AWS to bring those workloads to local zones near those on-prem databases so that this customer could continue to maintain a high bar of customer experience for the end users who are viewing and managing their health records through that SaaS application that were ultimately stored in those on-premise databases. And there are a variety of different use cases that I haven't even covered. And because there's such a variety of use cases for data residency, we truly believe that there's no one-size-fits-all solution for data residency in the cloud. This picture becomes even more complex if you consider data residency from the broader lens of digital sovereignty. Because we've noticed that customers don't just care about where their data is stored, they also care about the protections around it. For data residency, customers need to make sure that they know where their data is at all times and control where that data is stored or transferred. But at the same time, they need to make sure they can prevent unauthorized people and accounts from accessing that data. For data residency, customers need infrastructure solutions in particular locations so that they can meet their data residency requirements. At the same time, they need to make sure that those infrastructure solutions are resilient against failures, such as those caused by natural disasters or power outages. And the combination of what customers need to achieve across their digital sovereignty and data residency requirements can dramatically affect their strategy for architecting in the cloud. So we believe it's really important to work backwards from your data residency and digital sovereignty requirements and to understand the full breadth of infrastructure solution options that you have to meet your needs. So if everyone's data residency requirements are different, how do you ensure that you're building to cloud best practices while meeting your own specific data residency needs? The AWS Well-Architected Framework was designed to help customers build secure cloud applications based on design principles for the cloud. It offers information and tools developed through years of gathering insights from AWS customer best practices. And it provides information that helps customers flexibly decide on their designs for how to address their data residency requirements, while at the same time understanding the benefits and risks that are available as information to them in this tool. So what is the AWS Well-Architected Framework? Fundamentally, the AWS Well-Architected Framework is a set of questions and design principles across 6 different pillars. These pillars are operational excellence, security, reliability, performance efficiency, sustainability, and cost optimization. And the AWS Well-Architected Framework provides best practices that are associated to these design principles and these set of questions to help teams think through their architectures so that they can lower their risks and build faster. To illustrate how to use the AWS Well-Architected Framework to help design your applications for the cloud for your data residency objectives, I'm going to take an example from the security pillar, which has a number of design principles that are directly relevant to this topic of data residency. For example, there is a security design principle for applying security at all layers, with recommendations for securing your networking layers, your VPCs, your load balancers, every compute service, applications, your code, your OSs. There's also a design principle for protecting data in transit and at rest, with recommendations for using mechanisms including encryption, tokenization, masking, and access control. There's also a design principle for preparing for security events, where you'll find recommendations to run your own incident response simulations to ensure that you can find those issues quickly and resolve them rapidly. The AWS Well-Architected Framework provides a set of questions that are associated to each of these pillars that you can take to your teams to evaluate your posture related to those design principles we just looked at. For example, within the security pillar, there's an area for data protection and a question of how do you classify your data, which is a question that you can pose to your teams to assess your architectures. There's context for that question on what it's about, the scope, the considerations, and a list of best practices that are associated with each question so that you can learn from the best practices of AWS customers before you. Posing these questions to your teams help teams align on desired outcomes, identify common anti-patterns, and weigh your benefits and risks. And using the AWS Well-Architected Framework in such a fashion can be a powerful tool to help you assess your security posture of your application architectures. Within the AWS Well-Architected Framework, there are a number of considerations that are directly related to this topic of data residency. And today, I'd like to go through a few of the important topics that I'd like to suggest we spend some time on today. The first is that we recommend that you spend a good amount of time identifying your in-scope data classifications and the regulations that apply. Because knowing the regulations that apply to each data classification can dramatically impact the types of infrastructure solutions that you need, perhaps various infrastructure solutions that you need to meet your data residency requirements. And in fact, Singapore GovTech has actually gone through a journey of architecting for data residency across different data classifications that had different requirements, where some data classifications could reside in AWS regions in Singapore, where other more sensitive, regulated data classifications needed the enhanced security and governance features of AWS Dedicated Local Zones, which provided dedicated infrastructure to Singapore GovTech. And Kevin's going to talk a lot more about that in just a little bit. Use cases matter as well, because use cases have a direct impact on the types of services that you need to have supported in your infrastructure solutions in order to meet your needs. The services that you need for data analytics are going to be different from the services you need for machine learning, are going to be different from the services that you need for high-performance computing. And so it's important to look at that as well. And we also recommend that you spend some time to really think about the permissible locations where your data can reside. And we'd like to suggest two big considerations in this topic for you. One is to consider your own latency targets to your on-premise systems or to your end users, because identifying those latency targets can really narrow the scope of the locations where your data and your applications can reside. You can also, and we also suggest that you also think about those data protection mechanisms, some of which I've actually mentioned before: encryption, masking, tokenization. Because using these data protection mechanisms can potentially broaden the scope of locations where your applications can reside. And because you may have use cases where you're trying to comply with regulations, and regulations change, we also recommend that you spend some time to really think about how you might want to segregate the storage and processing of your sensitive versus non-sensitive data classifications to minimize the impact due to those regulatory changes. And as much as possible, we also recommend that you use a consistent experience of services, APIs, and tools, so that when you need to make changes across data classifications, across infrastructure solutions, the work is minimized because you're building on a common foundation. There's a lot to consider when it comes to architecting and building to address your data residency requirements. And once you've done the heavy lifting of determining your use cases and the locations that you can run your applications in and your data classifications, you'll want to know your options. So in the next section, I'm going to introduce a few of the AWS infrastructure solutions and options that are available to bring the AWS cloud to more geographic locations to address your specific data residency requirements. Let's start with AWS regions. So we've launched 34 AWS regions around the world with 108 availability zones, which offer customers more choice and flexibility with where to store their data. The majority of our customers use AWS regions to address their digital sovereignty and data residency requirements today, because AWS regions are sovereign by design. Customers have full control over their data. They control where it is stored, how it is stored, and who has access to it. But what if you have applications that need to run in a location where there are no AWS regions today? AWS hybrid cloud solutions extend the AWS cloud to more geographic locations to help meet the needs of data residency requirements of our customers. And I'm just going to highlight a few of the AWS hybrid cloud solutions that we have that extend the AWS cloud to you today. Let's start with AWS Local Zones, which are a type of AWS infrastructure that places compute, storage, database, and other services close to large populations and industry centers. We recently announced the launch of the AWS Local Zone in Manila, Philippines, for now a total of 34 local zones with 17 outside of the US. AWS Local Zones bring more geographic locations, more countries, more states, more jurisdictions, where customers can run their workloads to meet their latency-sensitive application requirements and comply with regulations. But what if you have applications that need to run within your own data centers? AWS Outposts brings AWS infrastructure and services to virtually any data center. Outposts come in full-size 42U racks or in smaller format servers that can be deployed in branch office locations. And Outposts are available in over 75 countries, effectively increasing the infrastructure options that you have today for running your workloads in your own data centers on-premise. And for customers who have broad digital sovereignty data residency needs and who need dedicated infrastructure to serve the needs of a community of users, we offer AWS Dedicated Local Zones, which can be flexibly deployed inside of AWS sites or in customer data centers and are operated by local AWS personnel. Customers can control which accounts create resources inside of their dedicated local zones. And AWS Dedicated Local Zones offer multi-tenancy features with elasticity, scalability, and pay-as-you-go pricing to facilitate the adoption by a customer community. AWS Local Zones, Dedicated Local Zones, and Outposts offer more locations and customers more flexibility with the locations where their data can reside. But we know that selecting an infrastructure solution based on location is only part of the data residency story. What about the services to support your use cases in those locations? AWS Local Zones, Dedicated Local Zones, and Outposts support a core set of services for local processing and data storage. And for EC2, customers have a choice of general or memory, storage, compute optimized instance types in their hybrid cloud solutions. For AI/ML use cases, accelerated compute is available in select local zones and in dedicated local zones, where customers can run their high-performance compute and machine learning workloads. For storage, Amazon EBS is available for persistent block storage, and Amazon FSx is available as a local file service in select local zones and in dedicated local zones as well. Amazon RDS, or Relational Database Service, is available in Outposts and in select local zones. And Amazon S3 is available in Outposts. And you might have also heard that we recently announced the general availability of Amazon S3 storage classes that are now available in AWS Dedicated Local Zones, which have been purpose-built to help customers build to their digital sovereignty and data residency requirements. In terms of security and governance services, AWS has over 50 security and governance services that can work with AWS Local Zones, Dedicated Local Zones, and Outposts. And in a little bit, Lakshmi is going to come on to demo how these security services can work in conjunction with infrastructure solutions and compute storage database services to help enforce your data residency guardrails. So by now you have an idea of the infrastructure solutions and services that may meet your data residency requirements. But you may also be wondering, if all my data is in the cloud, how do I know that my data is safe and secure? This is where the AWS Nitro system comes in. To help ensure the confidentiality and integrity of customer data, AWS regions, local zones, dedicated local zones, and outposts are powered by the AWS Nitro solution. For over 10 years, we've been reinventing the EC2 virtualization stack to bring more and more EC2 virtualization functions into dedicated firmware and hardware, and the AWS Nitro system is a result of that continuous innovation. By enforcing a strong physical and logical security boundary, the AWS Nitro system enforces restrictions to ensure that nobody, including anyone in AWS, can access customer workloads running on EC2. The security design of the AWS Nitro system has been validated in an independent public report by global cybersecurity firm, the NCC Group. So whether you're using AWS regions, local zones, dedicated local zones, or outposts, AWS customers can be assured of the security of running their applications on our Nitro technology, which physically prevents anyone from accessing customer data. We have a wide variety of customers who are using our AWS hybrid solutions, our edge services, and the Nitro system to achieve their data objectives. And here to talk to us about the journey that the Singapore government has gone through to architect their workloads for data residency, I'd like to invite our special guest speaker up on stage. Here's Senior Director of Core Engineering Products, Kevin Ng.
Yeah, thank you, Sherry. My name is Kevin Ng. I'm from Singapore. I'm the Senior Director of the Core Engineering Products of GovTech. And before I explain my role more completely, let me explain to you what GovTech is about. So, like most governments, right, in Singapore government, we are made up of multiple agencies. And even though Singapore is not as big as the United States, we do have a lot of agencies. They're all together about 100 of them. And these agencies serve different capabilities and purpose for the citizens as well as for the business. For example, we have the Economic Development Board that's all about spearheading to grow the economy of Singapore. And then we have the Ministry of Manpower that takes care of the labor laws. And of course, we have our equivalent of the Income Tax Department that collects taxes from the citizens and business. And our job, as stated on the slide, is to engineer digital governments and make lives better. And GovTech is very unique amongst government because most of the government in the world actually procure technology from external parties. Whereas for GovTech, we actually have internal capabilities. It means that we are able to design, develop, and operate our technology solutions. Of course, we still use external vendors and partners such as AWS, but we're quite independently capable of delivering our technical solutions. And what this means is that it creates a role for a person like myself to run the whole of Singapore government technology stack as a platform engineering leader. And that is what my goal is about, is to be able to supercharge Singapore digital transformation through faster developer productivity, as well as increased system resiliency and security while keeping costs value for money. And the Singapore government tech stack is made up of 3 layers. So at the bottom layer, we have the hosting layer. That's what we call government on commercial cloud. And you hear a lot of mention of this term, GCC, throughout this presentation, and it stands for government on commercial cloud. And next, we have the base layer. And we know that to develop for the cloud, we need to have tools that are suitable to be developed by the system developers and the builders to build consistently the architecture for the cloud. And to give some example, we have Apex. Apex is our API gateway and marketplace system. It allows us to standardize the gateway system, have better security, as well as have better visibility into the behaviors of the various transactions that's happening across the government. And then we have ShipHats. ShipHats is our continuous integration and continuous delivery solution. It provides us a way to consistently deploy good quality solution, security check to the cloud environments. And then I'll maybe spend a little bit of time on the service layer. At the top, you'll see this term called NDI. NDI stands for National Digital Identity. And like in most countries, we actually have an identity card that actually allow us to go to the government brick and mortar offices, right, to authenticate our identity and conduct the services. And of course, today we have moved into the digital realm. It's very important for us as we go onto the web to be able to authenticate the citizens or even the businesses. And National Digital Identity is indeed such a platform to allow that. And this service layer, as you can imagine, is then a set of reusable software components that you can build larger applications and systems out of. And this is a Singapore government tech stack. And next, I will zoom a little bit into government on commercial cloud. I think first of all, right smack in the center, it's important to know that this is not a cloud that we tuck one side and put in a data center. Of course, the cloud is in the data center, but this is the public cloud that all of you are using, except that this one, of course, resides in Singapore, the region. And what we have when we say government on commercial cloud is just this capability that we built around it to centrally administrate for all these different agencies. And one thing I should have mentioned, all these different agencies actually have their own IT teams. And so they also have their own platform teams. So in a way, we are the platform of platform. And what we do is to be able to create a general enough platform for all these agencies to come on board easily. And there are also smaller agencies which we need to support, and in those cases, they just leverage our platform directly. And I'd like to just go through briefly some of the basic capabilities. So one of which is around, at the bottom right, is around the ability to have baseline security controls to govern the way we want to set system controls for our workloads. And this includes one very important point that was mentioned, and the reason of why this presentation is all about data residency. So we are able to have controls to make sure that the data and the necessary services are within Singapore region. It allows us to simplify the policy such that it provides the guardrail for the workloads. And then we have the part where, on the left side, right, where we have simplified the onboarding. So before we had a commercial cloud, everything was on the data center, right? And this was pre-DevOps, meaning that once the developer finished building the binary, they would then deploy through the operations, a separate process. And I think once we start coming up and joining all this together and have better DevSecOps collaboration, we would need to have this simplified onboarding system so that it can come on. And it is a system that's built for system builders, for the developers. And of course, part of that process, because there are agencies, we need to cost reallocate, and so we centralize the billing. And on the top is more for the administrators to administrate the system. And this includes modern capabilities like centralized observability, as well as more traditional administration. And what this means is really the good old secure shell into the workload itself, and of course, through careful processes, right? And this is some of the parts that we need to provide. And I think this part is important because the government in Singapore is not homogeneous in terms of technology capabilities. We need to be able to provide solutions to support different maturity audiences and agencies. And finally, right, we have to have streamlined on-prem touchpoints because this allows us to connect back to the government network and to different hosting infrastructure. And today, even though a lot of our workloads on the cloud, a whole lot of them is still on-premise. And what this means is that we need to be creating a set of interoperability capability to move from on-premise to the cloud, especially for the data and for the users. And the phase one of this government on commercial cloud has been very, very successful. Last year, it was reported in this conference that 70% has moved on to the cloud. And this year, actually, we are very close to 80%. I don't think we'll ever reach 100%, but this is where we are today. So all is good, right? But at this point, we do have challenges. And this happened about 2 years ago. And this is where we started to conceive the idea of a GCC+. We are not very creative in the naming, but GCC+ kind of stands for an extension of what GCC can provide. And this reason for this is due to data classification. As mentioned, we have different classified workloads, and one of the highest classified workloads is called confidential. And for confidential workload, traditionally, when we think about this, we have always think of it as being on-premise, where we can have absolute control and physical separation. And this about 2 years ago, right, we are hit with a problem. The on-premise solution, the government private cloud, is due for end of life by June 24, which is about a few months back. And we have to make a hard decision, right? Whether do we continue on the on-premise solution and extend new licenses and new technologies, sinking in a lot of capital investment, or do we think about how do we structure the workload so that it can move to the cloud? And therefore, we need a solution that we can think of within a cloud environment that could provide additional security assurance and physical separation, as well as dedicated resource that can operate on the environment. And some of the requirements, then we start spelling out. So there are 4 sets of broad requirements. One of it is security requirements. So in the cloud environment that we have is a bit unique. We are hosting for all the 100 agencies, right? And what this means is that the workloads are commingled. And on top of that, each of these agencies actually outsource their work typically to a third-party provider. And this could be parties like a Cognizant or Accenture. And these are names that literally did implement workloads for Singapore government. And there's always this risk that if a breakup would happen, right, from one of the agency or even one of the workload, there's a danger that the blast radius will be huge. And therefore, from our security consideration perspective, it's important that we have isolation, not just at the agency level, but at a workload level. And sovereignty is really important for us as well. I think earlier on, Sherry has already mentioned about the complexity. And I think in this case, we already have the residency, data residency sovereignty met, which is the cloud is actually hosted within Singapore. But what's missing is that the resources, the compute resources, the storage resources, they're not dedicated to the Singapore government. And what we want in this new environment is that we want these resources to be owned literally, or figuratively, I should say, by the Singapore government. And we are able to control it more directly, and they are operated by local, trusted personnel that we have cleared by the Singapore government. And on top of that, we come from a platform engineering background, and it means that it is important that we create a cloud platform that enables the developers. And developer experience is something that we strive to meet as high a mark as possible. And like all governments, cost is, of course, a very important issue, and we must meet our budget objectives. And let me spend a little bit of time about the developer experience. So as we build up this environment, we need to ensure that the DevOps capabilities that were built onto the old GCC can extend into this GCC+. And what this means in technical terms, right, is that the CI/CD solution I mentioned about needs to be integrated, and we need to be able to deploy directly GCC+ through our CI/CD pipeline that we have already built. And we also have some agencies and some capabilities in Kubernetes solution. And this means that we need solutions like Amazon EKS, right, to implement what our implementation of Kubernetes, which is called CStack. And unlike some of the users of AWS, right, we have chosen to use a Terraform-based pipeline to deliver our infrastructure as code. And it's very important for us that we continue to do so. And we are very appreciative for AWS to offer a combination of proprietary technologies, such as Nitro, and open architecture to allow us to integrate with our existing tech stack. And after much deliberation and discussion, we finally landed on the partnership with AWS to co-create this notion of what we call a dedicated local zone, and what we call internally as GCC+. And this collaboration and partnership has been very strong. We have deep dive sessions with AWS technical personnel about what Nitro system about. And we understand how Nitro is actually being monitored and being secured. And we have worked together very closely to prioritize the necessary local services that we need in our particular dedicated local zone. And we have to think about how we can build additional services leveraging the public cloud. And I'll talk a little bit about that in the architecture in the later slide. And like I have mentioned a couple of times, we support multiple agencies, right? It's very important that the way we deliver this can be developed to support multi-tenancy. And each of these agencies, they should, to some extent, be able to manage their own cloud platform within an organization unit. And last but not least, right, resiliency is a very important topic for government, and we want to have an ability to build multiple dedicated local zones so that they can fail over from one to the other. And this is a very, very aggressive schedule for us. As mentioned, this started in 2022, and within a year, AWS was able to deliver to us the dedicated local zone. And from there on, the work is still not completed yet. We have about a year to migrate the on-premise workload to the cloud. And this is coupled by additional training that we need to give our agency's audience, as well as to our vendor community, remembering that they are outsourced. And on top of that, we would like to have a streamlined cloud management portal that we can continue to build a consistent interface of how users use the cloud. And as mentioned earlier, I'd like to talk a little bit about how we architect this at a simplified level. And one of the things we rely on is that because the dedicated local zone do not have all the services that we need, and especially the security services. And what we then work on is the ability to extend the services on the public cloud, which is our government on commercial cloud. And a lot of the security services are reliant on them, such as the firewall, the web application firewall, the WAFs. And then we also have the second portion, the failover resiliency, and this means that we need to build 2 dedicated local zones. And this dedicated local zone itself, right, within the dedicated local zone, they are isolated physically, and literally they are caged up. And we are able to have the personnel cleared before they are able to literally touch the machines or the resources, right, inside the cage area within a data center. And finally, the last part of it is the government networks. So we need to have a way to connect this GCC plus system, right, into the government networks so that they can interoperate not just with GCC, but even with some of the on-premise workload. And some of the challenges that we have for this, right, is the edge solution supports a subset of service locally. And we are doing this prioritizing with AWS, right? And we are very appreciative that we have worked very closely with AWS as we go through this, because it's not just a service itself. So for example, when we say S3 is available and generally available within a dedicated local zone, right? It doesn't mean all the features are available. We still need to work quite thoroughly with AWS to decide which are the priorities that needs to be in the dedicated local zone. And we're very thankful to this partnership to build up the right feature set for S3 services, for example. And then for data migration, for those who have done any cloud migration, you'll know that it's always a hassle. There's a lot of data and limited bandwidth. And we have to exercise a lot of creative thinking about having parallel data transfer, as well as literally even scheduling the data migration in a lockstep manner such that we can maximize the bandwidth possible. And lastly, we have a challenge around security policies. So like most government, we have worded quite a bit of security policy to secure our workloads. And when we went on the cloud many years back, we decided that it is more worthy for us to create a separate cloud policy. But what happens in this particular environment is that it's not quite entirely the full public cloud. And we have to decide between leveraging either the on-premise policy or the cloud policy. And at the end, we decided we should look towards to the future and apply the cloud policy. But it also means that we have to think about what are some of the areas that may not conform exactly to the cloud policy. And these are the parts where we make exceptions and changes, such that all the agency workloads can migrate. Because without the policy sought out, none of the agencies in a regulated environment will be willing to migrate their workloads. And once we sort this out, right, it becomes much more easier for agencies to start their migration, and this speeds up the migration. And I'm happy to say that this was a mission accomplished. There are altogether 41 agencies with 213 systems. Out of which 68 systems we were migrating into this new environment called GCC Plus based on dedicated local zone. And then 92 systems actually are rightly classified, and we went on to the public cloud. And some of the systems we decided we could reuse them. And what it means is that GovTech has a central agency, right, can build a system, maybe like a visitor management system, which is a very general system, right, that can be applied to all the agencies, and 4 of the systems fall into this. The number is not as big, partly because this is a confidential workload that we're talking about. And of course, there are systems in it that we still cannot move. They have to decide to continue on-premise. And one important thing to call out is that there are 43 systems that are decommissioned. And like all cloud migration, right, even for this confidential cloud migration, sometimes there's no need to lift and shift everything. It's worthwhile to decide when to retire a system, and this is a perfect opportunity to do that. And I think for some of the benefits that we have derived from using GCC Plus, right, is very similar to what we have in GCC. So we definitely have increased agility and innovation. And on agility, right, it used to be for on-premise workload, it can take up to a year to provision, to write the necessary paper, to get a budget before we can start. And now with this GCC Plus, we can reduce this to a much shorter time. And because the dedicated local zone is still not as instantaneous as a cloud, but at least it's much shorter than that 1-year timeline that I just talked about. And by leveraging on a cloud, a third-party provider, they are able to innovate on our behalf, and we do not need to innovate on all aspects of a hosting layer. And this is what it brings about: faster onboarding and faster development capability for system developers. And of course, there's increased resiliency because we have 2 dedicated local zones, and not only do we have 2 and we can fail over, this is designed in the way that how the regional cloud is being designed. And therefore, some of the service level guarantees, right, are very similar to what we have on the public cloud. And we reduce costs. Well, I'm not able to share the details of the cost reduction, but what I can share is that because of taking a commonalized approach, right, we can simplify the architecture, and we have consistent AWS infrastructure, tooling, as well as API, right, to make sure that things can be done in a simplified way. And this helps us reduce costs significantly. And finally, we improve security, because previously on an on-premise environment, we have different appliances and tools that we purchase from third-party providers. And there's no standard way to run this. And now, with the help of AWS, not only there's a standard way, there's the ability to have managed services that help us with all this security operations work. And this results in lesser security configuration errors. And I think as I kind of wrap this up, right, the future plans of what we think about is we need to think about our tech stack. It needs to be tightly integrated into this GCC plus environment. And this thing is very important because if we have a common control plane, so to speak, and I kind of see it as a development control plane, right, then you are able to deploy solutions at a much rapid pace and in a more consistent manner, increasing the availability posture as well as the security posture. And it's important for us as platform providers to continuously improve the developer experience. And while AWS provides the fundamental platform, it's very important for us as the platform provider of the government and build additional services that may be suited more for the government domain. And we need to focus on resiliency improvement as we even think about the 2 dedicated local zone ability to fail over, right? When we think about our workloads, it needs to follow the well-architected framework that was discussed earlier. And in this way, we can improve resiliency through education as well as fundamental capabilities. And finally, we need to work with AWS even more closely for some of the additional services, such as AI capabilities into this GCC plus environment. And when we think about this, it's not just everything put into GCC plus, it's a combination of what I showed in the architecture, where we can combine GCC and GCC plus to deliver for the workload requirements. And I think with that, I would like to hand over to Lakshmi, who will give a deep dive and demo of the system.
Thank you, Kevin, for sharing with us the Singapore GovTech use case. Hi, my name is Lakshmi VP, and I'm a specialist SA on the hybrid cloud team. Super excited to be here and deep dive and get into the demo right away. So we heard about the well-architected framework and the data residency considerations and how to use the hybrid cloud services. So to quickly touch upon how you actually start leveraging the hybrid cloud solutions to build a well-architected solution. First key step, as we heard, is to identify your compliance posture and your in-scope data that is applicable for your data residency compliance. Next, you consider the AWS infra options, such as the regions, or the hybrid cloud solutions, which is the Outposts, the local zones, and the dedicated local zones. And this is based on your specific data residency compliant location. And then you use the AWS services, such as the control tower with landing zone, organizations with service control policy, IAM, and so on, to design and implement those data residency guardrails to ensure that you're complying with your data residency using the well-architected framework. As we saw previously, AWS provides a spectrum of services to help you use it as your tool set to build a compliant solution. But for today's session, I'll deep dive into 2 of these services, which is the control tower with landing zone and AWS organizations with service control policy. I'll also show you a demo of how to use these in real-life examples. So the first service we look at is the control tower. It's a service that helps you set up and govern a multi-account AWS environment. And it also helps you automate and monitor your data residency posture. There are 3 different guardrails in Control Tower. The preventive controls prevent unwanted actions from occurring. The proactive controls automatically enforce policies on all CloudFormation deployments. And the detective controls detect specific actions when they occur, and they log it in the CloudTrail. So in this first demo, let's consider a multi-account landing zone setup with 20 preventive controls and 5 detective controls already enabled. For customers who need to comply by frameworks, such as NIST 853 or PCI DSS, can find those relevant policies grouped under this category. And controls under the digital sovereignty category that we heard Sherry talk about can also be found under Control Tower. For example, think about the proactive, the preventive, and the detective labels that I just mentioned a moment ago. You can find those labels for each of these services that are available within this category. I'm filtering here for a detective policy that immediately detects if an EC2 instance were to be associated with a public IPv4 address. Think about use cases where you need to ensure that your workloads are never assigned a public IPv4 address. You can select that particular policy, look at more details as you dive in, and select the necessary accounts that you want to enable or enforce this data residency guardrail for this particular policy. This way, Control Tower gives you best practice, ready-to-use, compliant policies to enable for as you start building your data residency design. The second service we look at today is the AWS Service Control Policy. It is a type of an organization policy that helps you manage permissions within your AWS organizations and also helps you build custom guardrails. But why build custom guardrails? As we heard earlier, there is no one-size-fits-all solution. Data residency varies between multiple different countries and different use cases and different boundaries. So some of the common scenarios we see our customers use service control policies, or SCP, are to restrict the data movement from one location to the other, or to prevent use of AWS services which are not relevant to your use cases, or even to maintain the data isolation or data segregation. Think about government or public sector industries or any regulated industries where you need to separate the sensitive and the non-sensitive data for processing and storage. In the second demo, let's consider, again, a multi-account setup within AWS organizations. You can see here that I have multiple accounts, the management account, the sandbox account, security accounts, and so on. Under policies is where you would find the service control policies to build your custom guardrails for data residency. You use these SCP policies to enforce the examples, such as preventing data movement or restricting the AWS services which are not relevant to your use cases, and for data isolation and segregation. Let's deep dive into one of these SCP policies and see how it actually works. Consider a local data processing use case where our financial customers have told us they need to keep their payment card information and processing details within certain compliant locations. Or even, as we heard from Kevin, where the GovTech example, they need to keep their sensitive or the highest secret workloads to be running within the dedicated local zone in this example. So in this particular example that we will look at, I'm using dedicated local zones as the compliant hybrid edge location, but this applies to AWS Local Zones or AWS Outposts, as well as regions too. Let's look at what this SCP has in it. So as we look at the details of this SCP blocks or denies launching any EC2 instances in any subnet except for the subnet ending with 02A02. In our example, this subnet resides within a dedicated local zone. So I'm going to try launch an EC2 instance using a launch template. At first, I'm going to try launch this EC2 instance in an AWS region. As you see, the subnet that I have selected is not 02A02. So when I try to do that, the SCP immediately blocks it. My action is denied because this is not an allow listed subnet under the service control policies. I'm going to try relaunching the same EC2 instance, but now I'm going to select the subnet which is allow listed within the service control policy. As you can see, I'm selecting the subnet ending with 02A02, which was allow listed in the service control policy. And this time, when I click on launch instance, the action is allowed. This way, customers can enforce data residency to ensure that the resources are not launched outside their compliant boundaries. So now that we know that we can restrict or enforce resource launches within compliant boundaries, how do you ensure that the data is not moved outside those boundaries after processing? For example, healthcare customers tell us that certain sensitive personal information of their end users should always be stored within certain boundaries, even after processing. Let's consider a data isolation use case and look at this particular SCP. It denies storing snapshots of or EBS volumes anywhere except in the dedicated local zone. So I'm going to try to quickly do a quick snapshot of an EBS volume that is attached to the EC2 instance we just launched. I'm going to try to store this in an AWS region. And we see that, again, the SCP denies the action. It's preventing me from storing the snapshot and moving it outside the dedicated local zones into the region. But the good news is that S3 storage classes have been available in Outposts for local data storage. And as we heard from Sherry earlier, we just launched storage classes for dedicated local zones too. So this provides you the ability to decide where your data resides compliant to your workloads and use cases. So what we saw today is only a tip of the iceberg in starting to design a well-architected solution for data residency. For those of you who want hands-on exercises, lab exercises, feel free to check out this well-architected tool at this QR code. So you are in control of where your data resides. And AWS provides you the necessary services and the tools to help you well-architect it. I hope this session has helped you think about how you can well-architect a data residency solution using AWS hybrid cloud services. Here are some more additional resources if you would like to deep dive into this topic. Thank you so much for your time this evening.